In this segment, we're going to be talking about something called functions. Now, most of you will probably remember what that is. In terms of a simple analogy, it's kind of like a machine. You put something in it, you get something back out of it again. In terms of variables, you have a dependent variable and independent variable. Those two variables make up an ordered pair. One of them is an input, one of them is an output. And when you put them in a machine, in this case, an algebraic equation that is a function, you will get a certain output. Now, without me trying to explain further, just using words, let's take a look at this concept on our board. Okay, I'm going to write a simple example of a functional equation on the board. The symbol for a function is this funny looking f, and then in parentheses it can be any letter representing a variable. Let's just use the traditional x, and it reads f of x, and then it equals, and this is our machine that's going to generate some kind of output, is some kind of an equation. We'll just say, make it simple here, x squared plus 5. Now, I said there was an input and an output. Usually, traditionally, the x-axis, if you were graphing this, would be your input. Your y-axis would be your output. And so we're going to give it just a sample input here. Let's just say that we want x to be 2. You would write that like this. We put a 2 in place of that x. And then it's a matter of just simple substitution. We have 2 squared plus 5. And of course, 2 squared is 4 plus 5, and our output is a 9. Now, it's never going to be something that simple on a test like the SAT. They're going to give you this basic concept, but they're going to jumble it with a bunch of other things that they want you to really have to think. It won't be this simple. So let's take a look at some typical examples. And these examples are straight out of your Princeton Review book. And by the way, you'll notice there's quite a few function type questions in the sample SATs. And that's because an actual SAT is going to have quite a few functional relationships that you'll have to sort out. Okay, here's a typical example. It's a number 14 problem, so it's at least medium level difficulty. And you look at it at first, you say, well, that's just like the simple example that I showed you a moment ago, where I had x squared plus 5 was your function. But let's see what they're asking here. If f of x equals x squared plus 2, which of the following could be a value of f of x? So what they're wanting you to do here, rather than plug in, these being inputs, they want to know what's the possible output. So right away, when you see x squared, you know that, let's take the smaller of the two here, minus 1. If I square to minus 1, I'm going to get a plus 1, I'm going to get a 3. That number is larger than anything here. If I put a minus 2 in, it's still going to be a number larger than anything I have here. And the same thing if I put in the positive 1 or 2, it's going to be too large. So what is small enough to get one of these answers? Well, we still have 0 to look at here. If I put 0 in there for x as my input, the output is going to be 2. So our answer is 2. Okay, let's take a look at another example here. This is a problem straight out of the Princeton Review book. It's a number 15, so it's a medium level difficulty. And probably part of the difficulty is that it's a word problem, and that usually freaks out everybody. But it's not really all that hard when we look at it. Let's look at it together here. Rock climbing routes are rated on a numbered scale with the highest number representing the most difficult route. Sally tried a range of shoe sizes on each of the several routes of varying difficulty and found that when she wore smaller shoes, she could climb routes of greater difficulty. Now, if D represents the difficulty rating of a route that Sally successfully climbed, and S represents the size of the shoes that she wore on such a route, then which of the following could express D excuse me, as a function of S? Okay, so what kind of relationship do we have here? We saw that the difficulty is going to get larger, and the difficulty is represented by this D of S, okay? And the smaller the size, the larger this D of S is supposed to get. So let's just take a couple of shoe sizes. Let's say a size 6 and a size 10. Well, if I put in the smaller shoe size, I should get a larger D of S than if I put in the larger shoe size. Let's see if that happens here. If I put in 10, I square it, I get 100. If I put in a 6, I get a 36. So obviously 100 is larger than 36, so you can eliminate A. Same thing with S. The square root of 10 is obviously larger than the square root of 6. And for S, 4 times 10 is obviously larger than 4 times 6. Same thing with D. I'm going to get a smaller number rather than a larger number with D. So the only one here that really works is the smaller you make a denominator, the larger the output of that improper fraction. So if I put a 10 in here, I would get a 4.5, but if I put a 6 in there, I'm going to get a much larger number, because 6 goes into 45 a lot more times than 10 goes into 45. So E is your answer. Okay, here we have another example. If f of 3 equals 6 and f of 4 equals 13, then which of the following could be f of x? Now, here's your possible generating machines. The 3 and the 4 are your inputs, and the possible outputs are your 6 and your 13. So, what we do here, and you can do it rather quickly, is just a matter of substitution. If we look at A and we put a 3 in there for x, obviously that works. 3 plus 3 will equal 6. But if we put the 4 in there and we add it to 3, we get 7, not 13. So you can eliminate A. On the second one, B, if we put a 3 there, we get 2 times 3 is 6. That works. But 2 times 4 is 8, and it's obviously not 13. We can eliminate that. On C, we have 3 times 3, which is 9, plus 1 equals 10. That's obviously not 6, so we can go on to the next one. On D, we have 3 times 3, which is 9, minus 2, which is 7, which is obviously not 6. So by a process of elimination, we know it has to be this one. But just to be sure, we'll go ahead and do the math here. If you plug in a 3 here, you get 3 squared is 9, minus 3 is 6. I put the 4 in there. 4 squared is 16, minus 3 gives you 13. So we've verified that it has to be E.